In this video, we are going to learn how to write a quartic function when we're given only two real roots. So there's a couple of concepts that you need to remember. One is vocabulary. So a quartic function is anything to the fourth degree. So to have a fourth degree, so we have a fourth degree function, which means we have to have 4 roots. Okay, so we're only given 2 real roots. So if we have 2 real roots, that means that we have to have 2 imaginary roots. Which brings us to another concept that's very important. Imaginary numbers always come in pairs. So let's write that down. Imaginary roots always, there's no exception, come in pairs. So the easiest imaginary number to deal with is the number I. So the easiest imaginary number is I. Okay, so just for review, remember that I is the square root of -1. So that's simply by definition. So that would mean that these are my 2 real roots. So I have 2 imaginary roots. So my imaginary roots would be x is equal to plus or minus I, and we can rewrite that to be x equals positive I or x equals negative I. So now I have 4 roots. 1, 2, 3, 4. So let's go ahead and write this out as factors. So we're going to rewrite these as factors. So my factor for x equals -3, I add 3 to both sides of my equal sign, and I get x plus 3. So that there is one factor. And then I have x equals 5. So I subtract 5 from both sides of the equal sign. I get x minus 5. That's my other factor. And then I have x equals I. So if I subtract I from both sides of my equal sign, I get x minus I equals to 0. So that's my imaginary factor. And then if I have x equals negative I add I to both sides. So I get x plus I is my other factor. So let's take care of our imaginary factors first. So what we're going to do is we're going to multiply x minus I times x plus I. I'm going to do this longhand, even though some of you may have already know what this is. So I'm going to do this as a box. X minus I, x plus I. X times x is x squared. Negative I times x is negative ix. I times x is positive ix. And negative I times positive I is negative I squared. So we can see on the diagonal those zero out. So I'm left with x squared minus I squared. But again, you need to remember that if I is the square root of negative 1, that I squared is negative 1 by definition. So that means this is x squared minus, well, what is I squared? I squared is negative 1, so this becomes x squared plus 1. So those are that's my factor when I multiply my two imaginary roots together. So now I'm going to multiply my real roots together. I'm going to do it the other method, which is by distributing. So x times x is x squared. X times negative 5 is negative 5x. Then I have to distribute the 3. 3 times x is positive 3x. 3 times negative 5 is negative 15. So I can see I have like terms here. I have to combine those. So I end up with x squared minus 2x minus 15. So that's the product of my two real factors together. So now what I have to do is I have to multiply these two factors together. And it's easier if I have a binomial and a trinomial to use the box method. So I'm going to set it up as a box method. X squared minus 2x minus 15 and x squared plus 1. So x squared times x squared, multiply same base, add exponents. Negative 2x times x squared is negative 2x cubed. Negative 15 times x squared is negative 15x squared. And then all this gets multiplied by 1, so it does not change its values. It keeps its identity. Let's look on the diagonal for like terms. Be careful. Not like terms. Our like terms are stretched out right here. So our final answer would be x to the fourth minus 2x cubed minus 14x squared minus 2x minus 15. And we're going to put y equals there because it asks for a function. So this is just one possibility. There are an infinite number of possibilities because I could have picked other imaginary roots. I could have picked plus or minus 2i. I could have tried plus or minus 3i. There's any number of imaginary roots that I could have chosen. But I chose the easiest one. This is always the easiest one to deal with. I and I squared become the easiest imaginary roots to deal with.